Hi again. At the end of the last video, I gave you this question. What is the probability for a standard normal distribution random variable z to lie between plus minus 2? What is the probability in between plus minus 2? And when you have when you need to calculate the probability on an interval from the CDF, we can use this formula. So probability between A and B can be split into probability smaller than B minus probability smaller than A. Again, please do not mind the weakness or strength of the inequality. The mode of inequality is not important in this chapter at all. So I keep using weak inequality just because it's my habit. Anyhow, here, if you use this, we have this probability between minus 2 and plus 2 equals to probability smaller than 2. It means CDF of 2, which means probability smaller than 2. It includes all the values smaller than 2. But you have to subtract the value even smaller than minus 2 because, say, for example, minus 3 is not included in this probability. So you have to subtract this part. Then the answer is 95.450. So it's about 95%. And you are going to see this number often, or it's a famous number because typically, as a rule of thumb, people say the standard normal distribution has 95% between plus 2 and minus 2. So plus minus 2 contains 95% of the observations. In other words, if the value is smaller than minus 2 or greater than 2, then it's exceptionally small probability, less than 5%, right? So exceptionally good or exceptionally bad. So just rule of thumb, approximately, if like when you have a standard normal distribution, you could predict something within plus minus 2 as a rule of thumb. So so far we have considered the CDF approach, and the CDF is defined as the probability smaller than something, always smaller than something. That's the definition. But using the information about the CDF, we can calculate the probability greater than something using the complement rule. Also, we can calculate the probability between 2 points using difference between CDFs. So, so we can calculate any probability. You can make the probability inequality more complicated, but still it's just combination of those. So the CDF contains all the available information about the distribution. So CDF is everything. Okay, then so far it was okay and easier to understand. But from now on, it could be more interesting and more confusing. It's truly like definitely it can be confusing. So now we will consider percentile. So remember from chapter 3 we considered percentile, and roughly speaking, the p percentile for z is defined as the value which satisfies the CDF the cumulative probability equals to p%, right? If it was 15 percentile, you have to have 15%. Like 90 percentile will be 90%. So given the probability, we are looking for A, that corresponds to the probability given. This is exactly the inverse of what we have done, because in our previous, like in the previous slides, a few pages, we have exercised how to calculate the probability when you have a value. Like what is the probability smaller than -1 or smaller than 2? Then I gave you a, the value a. Then you have to find its probability p using Excel or a table or a program. So a was given and p is what you have to solve for. In this problem, it goes the other way. P is given like 15 percentile, 90 percentile. So it's given, but what you don't know is what you need, what you have to solve for is the value inside the probability. It's a little bit more tricky, but Excel does the work. So don't worry, just don't be confused. Then you may find it easy enough. So we are simply speaking, CDF at the percentile should be the probability P, and you can find A by it. It means P is given and A is what you look for. So it's mathematically what we are doing is to invert the CDF function f. We are inverting function f. Then the inverse is, of course, we don't do it by hand, but the inverse function is built in. It's saved in Excel or any software, statistical software. So watch before doing this. Watch the Excel demonstration video, and from there you can find like the percentile, the value of the percentiles at any probability you want. And I chose a few typical percentiles: 5 percentile, 10 percentile, 50 percentile, 90 percentile, and 95 percentile. And as we learned in chapter 3, as the probability increases, the value increases, the percentile also increases, right? So 5 percentile means the bottom 5%, which is minus 1.64. And 10 percentile means the bottom 10% value. So it's larger than bottom 5%. Bottom 10% is larger than, no, bottom 10% is larger than bottom 5%. So that way, also we have top 5% and top 10%. So I already told you the answer. From these numbers, we would like to find the top 10% value. What is a top 10% value? The answer is this. The answer is 1.28. Graphically, top 10% value is this point. This point that makes the area equals to 10%. So probability, the area above or the right side of the value must be 10%. What is this guy? Or what is the probability greater than something equals to 10%? We are looking for this, and Excel tells you that this is 1.28. This is when you count from the top. If you count the probability from the top, it's 10%. But also, you may accumulate probability from the bottom. It's an equivalent way, but instead, if you count from the bottom, you have to accumulate up to 90%, right? So top 10% value implies that there is 90% below that value. So this is an equivalent expression. Of course, top 10% value equals to the bottom 90% value. it will be 1.28, right? And here comes another notation. It's a little bit inconsistent with the definition of percentile because percentile takes this approach. Percentile counts from the bottom and to this point. So in terms of percentile, 1.28 is 90 percentile. We say it's 90 percentile, but here we are going to interpret in the later chapters. It's not my fault. It's just a conventional notation in statistics. Usually, usually notation goes like this: Z subscript alpha denotes the value satisfies this condition. So probability greater than this value equals to alpha. So the top probability alpha value is Z subscript alpha, lowercase z subscript alpha. For example, Z.1 is the top 10% value or 90 percentile. And 90 percentile is the same thing, but 10 percentile is different. It's top 10% value, so it counts probability from the top in this approach. So we take this number. Um, so if you express this using the CDF, it satisfies probability smaller than top alpha probability equals to 1 minus alpha because alpha counts from the top, but CDF counts from the bottom. So this is why many students are confused at this point. But uh, we are going to use this notation a lot in the next slide and in the later slides. So I recommend you to get more familiar with this notation for this course and at this point. Uh, okay, so I am going to okay, and then try this. I have those numbers and we would like to find z subscript 0.05. Z subscript 0.05. So using this notation, what is the value we are looking for? Using this information and in terms of this notation, what does it mean? Try this. I will continue in the next video. Thank you for watching and see you in the next video.